We're going to look at two common forms for graphing linear equations. The first one is slope-intercept form. And now, slope-intercept form gives us these two pieces of information. It gives us our slope and it gives us our y-intercept. Our slope is our m value, which is always attached to the x, and our intercept is our b value. Now, it gives us the y-intercept, and the y-intercept is the place where it intersects the y-axis. And remember, our y-axis is our vertical one here. So when we have a y-intercept, we're looking for the point on our y-axis. Our slope is our rate of change. It's our rise over run. And our slope can give us an idea of steepness also, and whether the line is rising or falling. So if we have to graph f of x is equal to 3 minus 2x, what I want to first do is identify my slope and my y-intercept. Now remember, my slope is always attached to the x. So in this case, my slope is a negative 2. It's not negative 2x, it's just the coefficient, the number in front. My y-intercept is the 3. So when I go to graph this, I'm going to start by plotting a point on the y-axis at 3. So I go up here to 3 and I plot my first point. That's my starting point. Now I'm going to use my slope. My slope is negative 2. Well, if you think about rise over run, negative 2 we could write as negative 2 over 1. So I have to rise negative 2, which would be down 2, and then run over to the right 1. Or I can go up 2 and back 1, because I have to have one negative direction in there. So if I go down, that's my negative, then I need to have a positive. If I go up, I still need to have my negative, so I would go to the left. And there are 3 points, so we can now connect them with a straight line. Put arrows on the end of our line to indicate that it does go on forever, and there we have our graph. So we started by first identifying our slope and our intercept, then plotted our intercept, and then used our slope to get 2 other points. Now we're going to graph g of x. This one, my slope is the 0.5 and my b is the 2. Now 0.5 is really 5/10, so I can write it as the fraction 5/10, which I can then reduce down to 1/2. That way I have a fraction and I can see my rise over my run. It's a little bit harder to do it when it's in a decimal form. So I'm going to start up here at my 2, and then I'm going to do my rise over run 1 over 2. So I'm going to go up 1 over 2, up 1 over 2. Or I can go down 1 and back 2, because down 1 and back 2 is 2 negatives, and those are the same thing as a positive. Connect those, and now I have my g of x function. Okay, so what I want you to do is pause the video, and I want you to graph each of these equations. Start by identifying your slope and your intercept, and then graph each one individually. Okay, when you graph these, I have the f of x function in blue. I started at negative 4 because that was my intercept, and then I went up 2 and over 3 because my slope was 2/3. The g of x function, I started at a positive 2 for my y-intercept, and then my 0.4 was 4/10. That reduces down to 2/5, so I went up 2 and over 5, and then I also went down 2 and back 5. My h function is the one here in purple. So I started up here at positive 6, and then I went down 5 and over 2. Now a couple things you want to look at. You can look at the direction of your lines. My purple one has a negative slope, so I know that that should be going down and to the right, and it is. My green one and my blue one are both positive slopes, so they should be going up and to the right. As far as steepness goes, you can compare the steepnesses. A little bit harder to compare the first two. 2/3 is 0.6 repeating, and 0.4 would be the 4/10, so my blue one should be just a little bit steeper than my green, which it is. My purple is negative 2.5, so that one's definitely the steepest. Those are some things that you can also look at when you're comparing your graphs. Okay, that takes care of our slope-intercept form. Now we're going to look at another common form that numbers will come in, and that's called standard form. Now with standard form, we have ax plus by is equal to c, and then a, b, and c will all be numbers. First thing we're going to do is we are going to find our x-intercept. Now if you think about a graph, when it's talking about the x-intercept, it's talking about a place on the graph where it crosses the x-axis. And anytime we're on the x-axis, our value for y is 0. So if I want to find the x-intercept, I need to set y equal to 0 and then solve it for x. Once I have that point found, so let's say our x-intercept for a problem lands right there, then I'm going to go and I'm going to find the y-intercept. Well, with my y-intercept, the only thing I know about my y-intercept is that the x value will be equal to 0. So in order to find my y-intercept, I need to set x equal to 0 and then solve it for y. So I'm going to end up with 2 points like that. Once I get my intercepts, I can connect them and I have my line. So let's look at this one. Find the x and y intercepts for the equation 4x plus 3y equals 15. So start from the beginning here. To find my x-intercept, I put a 0 in for y, so I would have 4x plus 3 times 0 is equal to 15. Well, 3 times 0 is 0, so I have 4x is equal to 15. Divide both sides by 4, and I get x is equal to 15/4. Now, it tells you to find the x and y intercepts for this one. This is my x-intercept, so my point would be 15/4 because it tells me that's my x value, comma 0, because I put 0 in for y. Now if I do my y-intercept, to find my y-intercept, I need to set x equal to 0. So I would have 4 times 0 plus 3y equals 15. 4 times 0 is 0, so I have 3y is equal to 15. Divide both sides by 3, and I get y is equal to 5. Translate that into an ordered pair. It tells me y is equal to 5. And I used 0 for my x, so my point would be 0, comma 5. So I've found my x-intercept and my y-intercept. Now if it asked me to graph this line, once I have those 2 points found, I come up here and I plot them. So 15/4 would be right about there, and then 0, 5 would be right about there. Draw my line, and then I would have my graph. So when you're in standard form, you find the x and the y-intercepts, plot them, and then graph them. Okay, I will do the first one here with you, and then I'm going to have you pause the video after that. So it says graph each of the following. Our first one, we have 8x plus 4y is equal to 16. So I'm going to start by finding my x-intercept. So I'm going to plug a 0 in for y. So I would have 8 times x plus 4 times 0 is equal to 16. End up with 8x is equal to 16. I get x to be 2. So my intercept is the point 2, comma 0. Then I'm going to find my y-intercept. So I'm going to set a 0 in here for x, and then I'm going to solve it for y. So I get 4y is equal to 16. Divide both sides by 4, and I get y equals 4. So my y-intercept is the point 0, comma 4. Now I can go over here to my graph and I can plot those 2 points. So if I go over 2 up 0, I've got my x-intercept. Go over 0 up 4, get my y-intercept, connect them with a straight line, and there I would have my graph. So now go ahead and pause the video and do the graphs for these other two. Alright, on this second one here, 5x minus 10y equals 15. I found my x-intercept, I plugged in the 0, solved it all out, got x to be 3, so my x-intercept is at 3, 0. Then I did the opposite. I plugged in 0 for x, solved it for y, and I got my y-intercept to be negative 3/2. Make sure you take this negative sign with the 10 when you solve this. When I get my negative 3/2, I write that as my ordered pair, 0, negative 3/2. Plotted both of those points and drew my line. On the last one, same thing. I plugged in 0 for y. I solved it for x. Make sure this negative goes with that 6 when you solve it. And I got x to be equal to negative 3/2. So my x-intercept is at negative 3/2, 0. Then I did my y-intercept here. Plugged in 0 for x, solved it out for y, and I got negative 9/2. So I get the point 0, negative 9/2. plotted both of those, drew my lines, and there I've got my functions.